Hello and welcome back to compiler programming. In the last video, we managed to make the hello world executable work, and now we can print out this nice message. And I spent some time after the video to clean up disabled tests. However, when I came around to making this last test work, I realized that we do need to do a bigger change, and I didn't want to do it off screen. So what is happening here, let me uncomment this test. What's happening is that we have these two ways to deal with the rip relative things. And for imports, right now we have a bit of a divergence between what is expected for our JIT code versus what is happening for functions. In particular, we have this situation here that previously we would put essentially directly the offset in data inside the import, and then resolve this to the right offset. However, since the change in the last video where now we have this database RV, this is not really working like expected. Essentially, we are now not taking into account the offset of the data section itself when talking about imports. Let me try to show you what I mean. So if we run the test now, we crash pretty terribly. And if we try to follow on what's going on, then we'll see why. So let me open Visual Studio so we can see in the debugger what is going on. And from there, we can try to figure out what would be the best solution for this problem. So we are in this branch of code, right? And when we do program end, which is the thing that sets up correctly the code buffer and the data buffer, and these two pointers, we, by the way, can remove this stuff. This is no longer necessary. So we have the base virtual address of the code and base virtual address of the data. That basically just casts to an integer pointers to some buffers in memory, because for JIT code, that's all there is, right? We have just some buffers. And if we now go back to the test, this is what we are doing. We are taking the offset in data and saying that this is where we put in our import. However, now we go to the encoding and start following stuff here. We take the code base. So this calculation is actually pretty fine. This is okay. The trouble comes in here. So we take the virtual address of the import, and we are subtracting the address of the instruction. In the executable, this results in the correct behavior. However, in JIT code, this is not really true. And there are actually a couple of problems with this. The first is strictly a data problem, where if I go here and I look at this import name to RVA struct, the issue here is that this is just a 32-bit offset, and if we want to deal with JIT code, we might want to have it bigger. But also we have this difference where in the executable encoding, so basically here, this is where we are resolving these RVAs. We basically here use proper virtual address, but for JIT code, we don't really know that proper virtual address. So we have a bit of an issue. And we can go two ways. We can either change the code here to basically give us address relative to data buffer, or inside of here, we would do a similar loop as to this stuff and resolve, like basically add this base pointer to the offset. I think first I will try to do change here, because this seems just like an easier thing to do, because all we will be doing is we will be saying that minus header virtual address. So now what we are storing here, actually this is a wrong one. I think I want this one. Yeah. So here we would be storing the offset. And now I want to actually change this code, I guess, to reflect that, because I don't want to accidentally end up in a situation where I'm thinking it's one thing, but well, in reality it is another. So let's do that. I guess so we use this import name to RVA both for DLL and for the import itself. And I think I want to have two different versions now, because in one of them we will have relative offset, in the other one we will have absolute value. Okay, so let's call this symbol or import symbol, and here we would say this is going to be offset in data section, and then here I will just inline previously imported fields and say that this is proper relative virtual address. We'll have a bunch of errors, of course, but this is fine. We can clean this up. Okay, this file is fine. And then here we can clean up later. Let's check where else we have problems. We definitely have them here, but apparently we have so many problems in other files that it doesn't even get to that point. Okay, let's go one by one. Here we can just say we compare name, symbols, that's fine. So this is gonna be import symbol, and this is where the change will happen. So now we will say that we will take the database RVA, and here we will say that this is offset in data. Okay, sounds good. I missed letter P. Okay, that's fine. Where do we have all of these failures? Show me. Value C. Okay, let's go to value C and see what is going on. Okay, this is a very easy fix. Array import symbol. This is also pretty straightforward. Symbol, if I can find letter Y, that would be good. Okay. Import library, symbols. DLL is not a member. Yes, it is not. Now this is all just flat here. Must have a struct union type. What is the issue here? So this is our import library now. Okay. So what is happening? Is this the right array? Ah, we just have it called array. Okay. Image thunk array. Uh-huh. This is super confusing error message. It's like I'm missing a comma and it tells me something completely different. Oh well. Looks good. Okay. More changes to names, but nothing really complicated here. Let's jump to the next one. Okay, this is now the meaty part where we actually do need to pay attention to what we are doing, because this is where the main logic about the encoding actually lives. So let's keep our eyes peeled on what is going on. This is fine. This is fine. Fine. Okay. Make the editor slightly bigger. Here, just removing DLL. That's good. Okay. And now this is going to be offset in data. Okay. This stays the same. No more DLL, no more DLL, and no more DLL. Okay, not too bad. Okay, So this is where we have the issue, but we can still restore this. So we can say offset in data plus header virtual address. I guess. Leap. I know this is library. Sorry, I'm wrong. This is just like so. So this is fine. Okay, looks good so far. Where else do we have this? Well, we have now this is inside of the test. It's fine. We can fix that. And here now, this is pretty straightforward. We just copy from the operand. Yeah, this should help us do the right thing if it works, of course. Okay, we are building. let's try to run the test and see what is going on. Okay, well, that was a bit anticlimactic because it just worked from the start, which is honestly not too bad. Sometimes that is all there is. It just works. So that's good. Well, since we have a bit of time, let's take in the next thing and try to maybe extract this into something more reusable. In particular, this code. So remember how I said that we would need to process imports here? Well, let's just do that, because this is what this code does, right? It just goes through all of the imports and writes in the addresses that we get from the getProcAddress function. Okay, that is fine. Let's see if we can extract this. So we need to go through all the libraries, go through all the symbols. So we'll just grab this code over here and paste it over to here. Maybe I actually did the wrong choice about which way to go, because now we end up doing this anyway, but it's fine. As long as it works and as long as it's not too ugly, that's perfectly fine. Okay, so we have the C function import, and ideally this is all I want to have. So if I now go to the top and see how it works for the programs, this is what we do, right? We just say C function import, specify the DLL that we want to load it from, and everything else is handled automatically. Like all of these stuff, this has nothing to do with imports, and this is just regular reservation of values and so on and so forth. So here we would like it to be exactly the same. So all of this stuff needs to go somewhere and do things. So it needs to go into here, and we don't need REA for library. This is actually not used in a JIT code, but we do want to have it for the functions themselves. So let's figure that out. Okay, we have a library, right? We want to load it. Ideally, we probably should, like, I'm not even sure this will work if we try to load the library more than once. I'm not sure what will happen. Like, will it give us the same instance, or it will like just complain that we try to load library multiple times? We'll figure it out. If we have to cache it somewhere, we will. That's not really a big problem. So here we just say that this is gonna be lib. Yeah, lib name. We for now just assert that we were able to load this. DLL, let's call it DLL. DLL handle. Okay. Let me grab all of the remaining stuff because I didn't actually paste it, which is not good. So now we need to do something with this stuff and give us the right offset and data. Okay, let's do that. So we create a global value, and then we just say that it is at that offset. That actually seems pretty straightforward and okay. So assert, Let's say function address. So this will be function name, right? So we take DLL handle, we try to load the function, we assert that we were able to load the function, then we create a global value in a data section that will hold the pointer to there, and we put the pointer there, right? And then we just actually don't need to do this stuff, I believe. No, we do, because this is well, this is this thing, so we don't actually need to find it. So we just say function, and we can remove all of these jazz. We can remove all of these, and ideally, if I haven't messed up anywhere, this is all that we need to do. So we might need to change this stuff. Now let's see where we are. Okay. So the issue is that at this particular point, we don't actually have a descriptor to the function, right? And here as well. Well, actually here we do, but over here we don't. In reality, when we are doing the encoding, we don't really care about this stuff, so I think this stuff should go away because we don't need this. So I think a better option would be to just not use value global, but take a look at what LA global does and do that ourselves. And all it does in reality is just it allocates the size of the function pointer, and we will write there. That's it. So it is actually easier to not deal with our values or anything like that. We just get a pointer and we'll directly write to it. So we say reap address or reap target, and program data buffer size of, so we know exactly how big we need to allocate because this is JIT code and we know what is the size of the pointer. This is what we pass here. And now here we just write out the function address, I guess. Something like this. Okay, now we want to know what is the offset of this, which is pretty easy for us to find. We can say a 64 offset is, well, actually we can get it much easier. We can just say program data buffer occupied. Okay. And this needs to be before we allocate, because like when we do allocation, we take the end of the buffer and we get the pointer to that end of the buffer. And the size before that pointer is exactly the offset, right? So this should be fine. Let's see what we have at the moment. Okay, something did not work really well, but this wasn't. This test actually is passing fine. It is somewhere else where we have a bit of an issue. And probably this comes from here where we say if program import libraries or something like this. I suspect that we might have a null pointer there. So let's check that. Yeah, it's a union type. I think it's called data. Okay, it's called typed, and that, not that as well. Okay, I give up. I need to look up what is the actual thing that we use for the array. Internal. Okay, so I guess we can do array. Okay, that's what we will put there. Basically, if we haven't initialized that array, there will be a 0 in there, and we should not go. So let's see if my guess is correct. Apparently, okay, that should be like this. Okay, so it looks actually fine. Let's check that we have this stuff here. Yeah, this test is passing like it should. We have all the other tests passing as well. And now it actually looks really nice, right? It doesn't matter if we do JIT code or if we do actual executable. We just say, oh, I want to import this function from this DLL, and this information is very easy to find. You just go to MSDN and look up these things. We can parse now pretty complicated function signatures, and we can just use this anywhere we want, which is really, really neat. I think that will be it for today. We are in a pretty good shape to start marching on forward. So hopefully either next video or one after that, we will start working on some syntax and lexing and parsing, which is pretty exciting. For now, that's it. I see you next time.